All right. Happy Tuesday, 8th graders. We are moving on to Module 2, and we are going to start with some exponents. So today we're going to talk about the product of powers property. So thinking about those words, product is the answer to a multiplication property. So we're going to be multiplying numbers with exponents. For starters, you see that 2 to the 4th right here. Think about how we would read that number, 2 to the 4th power. So 2 is called the base. That big number is the base. And the 4 is called the exponent. Okay, so when we multiply something by itself, we are squaring it. So for example, 2 to the 2nd power is 2 times 2. So 2 to the 3rd power, we're multiplying it by itself 3 times. So 2 to the 4th power, multiplying it by itself 4 times. So that's expanded form. You're going to hear us say exponential form, which is this right here with the exponent. Expanded is all the numbers written out, and then standard form is the actual number. So you should have a calculator, Desmos calculator, to use, and you're going to do 2 times 2 times 2, or 2 to the 4th power. So when you put that in, you should get 16. Okay. We're going to move on, and we're going to try to actually simplify some. So notice on 1 and 2, it says exponential form and standard form. So exponential form is we're going to write our answer still with exponents, our number. We're just going to simplify it. And standard form is the actual number. So first things first, let's break it down. So 2 to the 3rd power. I'm going to expand that. So 2 times 2 times 2. So that's a lot of 2's we're multiplying there. Then on the other side, we have 2 to the 4th power. So I'm going to expand that. 2 times 2 times 2 times 2. All right. Count all those 2's. How many 2's are we multiplying? So you should have counted and got 7. So this is the same thing as 2 to the 7th power. Let's try to make a connection here. How did we go from an exponent of 3 and 4 to 7? Hopefully you're noticing that really all we're doing is just adding those exponents. So that's a quicker way. So we would just make sure you have the same base and you add the exponents. So standard form, we're doing 2 to the 7th power. So hopefully we have a Desmos calculator open. So on the Desmos calculator, you're going to do 2 to the 7th power. And hopefully when you do that, let me see, 2 7th power, you should get 128. Apologize. Awesome. All right, looking at number 2, you notice how there's only an exponential form, there's no standard form? Take a minute and think why there might be no standard form. Well, notice here we have just an x. We don't have an actual number. So nothing we can really put in the calculator. But let's just expand it and make sure what we figured out in the first one is true. So x to the 5th, I have 5 x's times x to the 3rd. So then I have 3 x's. So if you count all of your x's, how many do we have? Hopefully you counted 8. So we have x to the 8th power. And again, that quicker way we could have gotten there is looking at our exponents and done 5 plus 3 to get that 8. All right, so let's use that strategy here moving forward. So first things first, I want you to double check you have the same base. So looking at number 3, do you see how both of our bases are x? I know my base is going to be x. Now taking a look at my exponents, I'm just going to add them. So 6 plus negative 4. What is 6 plus negative 4? Hopefully you're thinking positive 2. So x to the 2nd power. Okay, let's do the same thing with number 4. So again, checking my base. Yes, my bases are both 5. So my Base will still be 5. Looking at my exponents, I'm going to add 2 plus 3. 2 plus 3 is 5. Putting this in our Desmos calculator. So I have 5. I'm going to hit that function button. A to the B power, and then 5. You get 3,125. All right, so moving forward, take a look at number 5. So something a little different with 5. Hopefully you're noticing that the first number doesn't have an exponent. Well, just try to envision, if I were to expand this, I have a 3 there. Then I'm multiplying it by 3 to the second power, so 3 times 3. So total I have 3 3s. So this becomes 3 to the third power. So if you ever don't have an exponent, just remind yourself that's an invisible 1 there. So thinking about standard form, 3 to the third power, and you can try to do this in your head, thinking about 3 times 3 is 9, 9 times 3 is 27. 27 is one of our cubes too, so hopefully we knew that one. All right, number 6. I have all 2's as my bases, so I know my base will also be 2. But notice we have a number here without an exponent, so I'm going to add in that 1 so I don't forget. Now we're going to take a minute and add all of our exponents. So 2 plus 2 plus 6 plus 1. So take a minute to add those numbers, 2 plus 2 plus 6 plus 1. Hopefully you got 11th. We can put that in our calculator and get 2,048. All right. We're going to flip that page over and just kind of sum up what we did here on the front. So when we multiply powers, with the same base, what did we do to the exponents? We added the exponents. So a way to represent this with algebra, in other words, with variables, so if we have a to the m power times a to the n power, it's the same thing as a to the m plus n, adding those two exponents. Okay. So again, that's a product of powers property. Remember when we multiply powers, making sure we have the same base. Okay, taking a look at numbers 7 and 8. We want to circle all the equivalent expressions. So first thing first, I want you to take a minute and see if you can eliminate any. So see if you can eliminate any. Taking a look at A, do you notice how we have two different bases there? So I know I have to have the same base, so I'm going to eliminate that. If we have 2 to the 12th power, and I put that in standard form, I'm multiplying 2 times 2 times 2 times 2. It's a lot of 2's there. So it's going to be quite a big number. Take a look at the last two, E and F. Standard form is one of those two numbers. So a common mistake people make sometimes with exponents, they say 2 to the 12th, and they think 2 times 12. But remember, that's not the case. We're multiplying 2 by itself. So I'm going to eliminate this. When you put 2 to the 12th in your calculator, hopefully you take a minute to do that, we do get 4,096, quite a big number. All right, we've identified 1 and eliminated 2. So let's go look at our other choices. B, we have both 2, so that works. When you multiply the same base, we add our exponents. 2 plus 6, that's only 8, that's not 12, so I'm going to eliminate that one. Looking at C, again, adding my exponents, 7 plus 5, that is 12, so that one works as well. Let me box it like the other one. And then the last one, we would add what's here, 10 plus 2, which is 12, so that one also works. All right, looking at number 8. Again, are there any we can eliminate right away? Notice we want x to the 6. Take a look. Are there any that don't have a base of x? Hopefully you notice B. That has a 2, so I'm going to eliminate that one. And also F. That is bases of 2 as well. So I'm eliminating those right away. Looking at A, in my parentheses, 1 plus 5, which is 6, so that one works. Looking at C, notice I have a number without an exponent. So remember that's an invisible 1. So thinking about 5 plus 1, which is 6. So this one works. D, again, I'm adding 4 plus 2, which is 6. So that works. Then the last one, 3 plus 2, that is not 6. So that does not work. Okay, we are just about done here. This last part right here. Explain why the exponents cannot be added in the product 4 to the 5th times 7 to the 5th. Use math and vocabulary. Math, vocabulary, and complete sentences to answer the question. So taking a look, what is wrong with this? Why can we not combine and add those exponents? Hopefully you notice right away the reason we cannot. So the exponents cannot be added because they do not have the same base. Sorry, I'm getting a little something. Excellent. Great job. You can move on to your independent. I hope you have a wonderful day.